So first off, I just want to thank you guys for coming to this presentation because, as you'll see here shortly, this is a topic that is really, really important to me personally and something that I care a lot about. And so just having you guys here to check this out and, sharing my progress and, encourage me along, it's so meaningful to me. So I really appreciate that. So I'll go over real quick what we're going to cover today. First, we're going to go on a technical and creative journey. We will explain my problem statement, which is what drove me to this crazy project, right? We'll iterate through the solution, how I kind of happened upon the result, and touch just a little bit on future work, where I want to take the project and all of that. We'll do a short live demo, which I'm most excited about, and which is why there's so much equipment in here. And there will be time for questions and cake. So let's talk about some prerequisites. First, I'm Alex Markley. Hi, everybody. And I like to make stuff. That's probably the single most important thing you need to know about me. I'm a software engineer, I'm a music composer and a writer, but my favorite thing to do of all time is to produce comedy and post it online. Just produce comedy with my brothers and sisters, publish it, put it online. So let's talk about the Malik's Minute. This was a show that was an audio podcast show. We produced over 200 episodes between 2006 and 2010. So very, very prolific. We had 3 characters. We had Malik's here, which is, he was just sort of a goofy, hapless programmer. And Linus, the laptop, very sarcastic sort of individual. And then Snufflefungus, the excitable furball. So those were our characters. And for whatever reason, we always got positive feedback from this show. It wasn't a huge success or anything like that. I'm sure none of you have heard of it, but we had a lot of fun with it. So as versatile as the audio format was, and this is the problem statement, right? This is what drove me to kind of explore this technology and this software and how to code this solution. We felt constrained by an audio-only format. Some of our target audience just was not captivated by audio, so we needed to figure out something about that. Again, limited target audience appeal. People like to see more visually. And frankly, with this particular show, as I was writing it, I had pictured in my head a sort of a cartoon format. But not just any type of cartoon. Specifically, something like Who Framed Roger Rabbit, right? Which is a Zemeckis film. Here's a clip if you haven't seen anything of it before.
Ah, that's better. I can't believe they locked me up for driving on a sidewalk.
Come on, Eddie, get in!
It was just a couple of miles. I'll drive.
But I want to drive.
No, I'll drive. I'm the cab. Out of my way, pencil neck.
Okay, so as you can see, just a goofy movie, a lot of fun, but a very specific aesthetic, right? We have flat 2D animation, and we have live action. We have characters that are human and characters that are toons. So it really kind of killed me inside that our podcast format really didn't allow all of that creative vision to come through. So how can we bring these characters to life on the screen? And there's one caveat. Our operating budget is $0 per forever. So small problems, right? It's just the little things. So let's talk about some early work real quick before we dive into the YerFace project itself. And I do want to add one caveat here. I know this is a code camp, and so I do apologize in advance that there's not going to be a ton of code on the screen. You know, we're going to be talking more concepts and higher level stuff. But I promise I will make it up to you in the fact that the entire thing is open source. All of the code is out there, and I would love for you to go check it out. There will be links to it, and we can, talk about it and continue to work on it together if you're at all interested. So that's my caveat about CodeCamp. But anyway, so what we did, pretty much the first thing I did was I looked at Blender, which if you're not familiar with it, it is an open source 3D animation and graphics tool. But at the time, it was not in any way mature the way it is now, and it was extremely impenetrable to figure out. So really just kind of left that one on the floor. We even looked at puppets, like literally like doing puppets and just filming that, and it just didn't, it felt like too much of a compromise. So in 2010, we produced this demo. So that was actually a lot of fun to do, but we did it in Apple Motion, and it was a 3D environment with 2D sprites. And the problem that we ran into was, as cool as the results were, it was so much work. Like, it was all the work of doing 2D animation, plus all the work of doing 3D stuff, and it was just extremely not sustainable. So finally, we confronted Blender in late 2013, figured that out, and came up with something like this. So this was really where I started to make progress in actually modeling and generating some toonish imagery. But one of the main concerns that I had was, if you saw the 2D animation, his fur bounces. It's very dynamic. And I was very concerned that a 3D mesh was going to just be sort of static, and we were either going to have to animate each individual bounce, each individual fluff, fur bouncing, or it was just not going to work out. So we tried to lean on some physics simulations to get us where we wanted to go. Didn't always work out. So unfortunately, we lost a lot of snuffle fungi. But it did eventually work out. By 2014, I was getting results that looked like this. You can see the fur is bouncing. You know, he looks fluffy. He's extremely happy, which is great for him. And so I was really excited about this. But so even though we don't have to animate the individual pieces of fur bouncing at this point, we still have to deal with the very hardest part of animation, which is facial expressions, speech. And see, from my perspective, I thought I was doing great because, you know, these were not characters with articulating limbs. Both of my characters are just heads, you know, like, I don't know, a fuzzy Bob the Tomato, basically, that just bounces around and talks. So, but I still had to deal with facial animation. Not having limbs doesn't, you know, obviate the need for facial animation, basically. So, going back to the core issue at play here is that, again, our operating budget is $0 per forever. It has to be easy. I am a software engineer full-time. I'm a husband. I'm a father of two boys. And if this thing is not super easy to do, then the whole project is doomed. We're not going to be able to get it off the ground. So fortunately, thinking about this problem, the gentle voice of inspiration spoke to me, and it said, try performance capture, you dummy. And if you're not familiar with it, performance capture is a really common technique in Hollywood to take an actor's face and convert that into mesh data, retarget that to a CGI character, and you get these pleasant results. So, question that I had was immediately, well, somebody's already solved this, obviously. What tools are out there to do this? So we looked at something called faceware technology. And these are just basically coming up on Google searches, right? Performance capture software, boom, faceware technology. And I mean, the screenshots, which I pulled off their website, it looks great. You can see this guy, he has a face, and then his character also has a face. So it's got to be legit. And also, wow, they have a really serious studio. So these guys know what they're doing. I wonder how much it could possibly, holy hell, that is really expensive. We can't afford that. What about something else? There's got to be other people out there. This one, it's not even pronounceable, Dynamics YZ. But he makes up for it because of how excited he is. Look at that guy, man. And also, he's got another cartoon character on his website, so looks like he's doing some good business. Can't possibly be as much as $900 a month, right? Well, the Wi-Fi might be not. Oh, yeah. That's way too much. There's no way we're going to be able to afford that. So what about, how does the Blender community handle this problem? So I started digging into this, and it turns out it's really not very well documented, and it's not a very supported solution. But there are a few people who have made some progress basically using Blender's internal marker tracking capabilities, which are optical flow tracking, and then connecting those to bones, which then drive shape keys. Okay, so I thought we can do this. How hard can it actually be?
Yeah, I know.
That one that we could possibly get of someone's face. It's
Right.
like, you know what time
Yes,
it
that
is.
camera is bolted to
You
his
know
head.
what I'm saying.
Time to spin the
Sibling
wheel of
abuse is real,
reality.
people.
I did. There was a man there. He had a puppy. He asked if I wanted to come home with him and see all his other puppies. There was a man there.
Oh?
He had a puppy.
Oh.
He asked if I wanted to come home with him and see all his other puppies.
Oh no.
Of course I said yes.
Snufflefungus, you know better. Stranger danger is real. You have to be careful.
I was careful, and oh boy did he have so many cute puppies.
All right, well, I guess it could have turned out worse. Next
He
time...
also had a dozen children locked in his basement, and he tried to lock me up too.
What?
So we had a battle. It was scary, but I won.
You won?
I defeated him and freed all the children. They each went home with a puppy.
So, not bad. I ended up doing a lot more work on this than I would have if I had just done the keyframe animation, because tracking the markers was a lot of work, and it didn't even produce the highest quality result. It really wasn't as dynamic or as full of life as I was looking for. So I thought, well, how hard can it be, right? Let's just make some software. I mean, that's what we do, right? We're programmers, so we solve problems with programs. And I knew some other work had already been done, so I figured, you know, let's use some libraries out there. The problem of detecting faces turned out to be solved already by OpenCV, which is another open source project that has computer vision capabilities built in, just a ton of them. But it turns out that the algorithms they have built in are super out of date. So that will factor in a little bit later. But this is where we kind of started. Also, OpenCV is really good at splitting out color-based things and just kind of doing region detection and things like that. There's a ton of great stuff there. And so made a little bit more progress with that. However, once we isolated the markers, now what? I've got a whole list of regions of interest on the screen. How do I identify what is the difference between an eyelid and an eyebrow, or you know, a cheek versus a mouth corner? So this was it was a pretty hard problem to figure out. I started out by using a domain-specific approach, which basically meant I figure out if it's a marker inside of an eye box, then it's probably an eyelid, and if it's above the other one, then it's probably an upper eyelid versus a lower eyelid. As you can imagine, it was pretty fragile, and it almost paid off. It got us moving in the right direction. So then I ran into another problem, which is basically, okay, if I have my eyebrow marker on the screen and I do this, what's the difference between this and this? From a human perspective, it makes total sense that they're not in any way related. But from the computer's perspective, it's just a dot moving up and down on the screen. So I wanted to avoid having to continue bolting cameras to actors' faces, because they didn't appreciate it as much as I expected them to. So, and then plus, I figured if I could reverse engineer the correct orientation of the actor's face, then I would actually have more data to pipe into the animation program. So, well, now we're going to go through all the stuff that I just said. So yeah, this turned out to be a pretty hard problem, but let's talk about something called PNP solving. So let's assume that you have a model for projecting points backward and forward through a camera matrix. From there, if you have your 2D projected points of what was actually seen by the camera, and then you have 3D world points, you already know what the objects, the points are. Let me say this again. If you already know the points' relationship to one another in 3D space, in real world coordinates, so you have your known 3D model, then you can reverse it with something called a PNP solve and get a recovered position and orientation of that object. So, first question, how do we get a camera matrix? Where is that going to come from? Because as you may or may not know, a camera matrix is necessary to correct for the necessary distortions in every camera lens. So it turns out we can just fake it, because if we pretend that our camera is ideal and has no distortion, then it still seems to work. So yeah, that's fine. All right, what about 2D points? Okay, so now there's a new open source library out there called dlib, which is a C++ machine learning library. And they have models built in that will actually recover skeletal points on the face. So you can get points that aren't, real fleshy, and use those to build your 3D model, and then voila, you can use those points as your input 2D models. I also found out that dlib has better models for, more state-of-the-art models for detecting faces in images, and all of those kinds of things. So I completely stopped using the OpenCV models. Now I still use OpenCV for a ton of other stuff, right? They even have that PNP solve, that PNP solution is completely baked into OpenCV. Just OpenCV knows how to do that. So, so I'm basically just a total charlatan. I haven't had to really write any code yet. So we use dlib's models. We get the points, we get the face, and then what about a node 3D model? Because we need to know the relationship of the points to one another in 3D space before we can solve for the pose. But it turns out, again, averages are fine, and Wikipedia actually has a page called Human Head that has all the information you need to figure this out. Hey, why not? So, success. We were able to recover the pose, and the program is able to identify in real time the exact location and orientation in 3D space of the subject's face. Okay, so now let's talk about markers. As you saw in the video before, where we started was using neon or fluorescent markers on the actor's face. And it turned out to be just a ton of problems. I think I explained already the domain-specific approach for identifying which marker represents what in the image. It was never totally stable, and we did evaluate at the very beginning using points that were coming out of dlib's facial landmark recognizer, right? But it had some problems because it's biased toward people that are smiling with their eyes open. I wonder why. There's a lot of images out there, photographs of human beings smiling like this, right? There's not a lot of images in the machine learning data set of people doing this or this. So it really is not that great at finding those landmarks in those faces. And in fact, what happens is it just completely blows up. So you've got, it just doesn't know what to do with that. Now, I could try to retrain the models with a massively improved data set, but I do not have a research grant for this work, and so it was really kind of out of scope. Again, $0 per forever. So we just decided, after some testing and after really comparing side by side the marker-based approach with the markerless approach, ended up saying, you know what, markerless approach is good enough. Let's make some more progress with that. So now we do have another problem because we've got the 3D location and position of the face, and we've got a screen coordinate of markers. Now, how do I identify the relative position of that marker to that face? And on the surface of it, it seems pretty reasonable. You've got your screen coordinate and you cast a ray, and at some point it intersects with a face, right? And that face is, at that point, that's the location, the 3D location of where that is, and then you can subtract the position and orientation of the head, and you have the relative position of the point. But this turns out to not be possible because you don't have the actual geometry of the human face, let alone that face making that exact expression. So your ray intersection is going to be inaccurate no matter what you do. But if you're noticing a pattern, we end up just winging it and treating the face as a plane. So you just do a ray plane intersection, which is really easy, and it's good enough, right? And again, part of the thing to keep in mind here is this is not a Hollywood production. We are not trying to do photorealistic animation of, with mesh retargeting. All we're trying to do is to inject some expressiveness at high quality to create cartoon animation. So this is totally reasonable, and this is the direction that we're going today. So we end up with success, right? It actually, now this is from an earlier version, so it's marker-based, but you can see on the bottom right, those are the recovered 3D points. And it's not, going too crazy when the face moves around. So now let's talk about lip syncing, because this is another area where I ran into problems, and it forced me to, what I think this is the main innovation that the YerFace project brings to the state of the industry. Maybe I'm wrong, but from what I can tell, this is a fairly cool innovation. So one of the problems with just using markers on the face to get the mouth movements out is that a lot of your articulation of speech happens behind the lips. Your tongue is moving, your teeth are moving, and that's what allows you to form phonemes, right? The basic building blocks of speech. So traditionally, cartoonists don't even look at a video of the performance. When they're doing 2D animation, they listen. They listen to the audio, and they break down the speech into its component parts. So I thought, well, is there a way to do that with the computer? And again, I mentioned modern performance capture, I think, currently does not do this, but I wanted to be able to, I wanted to do a fully automated phoneme breakdown of the speech into keyframes. And it totally turns out that this can be done. Carnegie Mellon University has been working on speech recognition for over 20 years. And so the CMU Sphinx project has the ability to run as a library, analyze audio, and produce phonetic output. So I just described this Herculean effort, this ridiculous journey of trying to figure out a way to not have to do any manual animation and still get the results that I was looking for. So how does it look? Let's find out. This is a clip you just saw. I guess it could have turned out worse. Next
He
time...
also had a dozen children locked in his basement, and he tried to lock me up too.
What?
So we had a battle. It was scary, but I won.
And this is something I just read
I guess
today.
it could have turned out worse.
He
Next
also had a
time-
dozen children locked in his basement, and he tried to lock me up too.
What?
So we had a battle. It was scary, but I won.
So there you go. That's much more like what I was looking for, because I wanted it to be dynamic, I wanted it to be full of life, and I wanted you to be able to see in the mouth, if you pay attention to the mouth, I wanted you to be able to see the articulation that goes into producing speech, right? But not in a photorealistic way, in a traditional 2D animation sort of a way. So I felt really good about that. So let's talk just a little bit about performance. As I was kind of thin slicing through this, I realized that I was in trouble when it was taking like over 100 milliseconds to process a frame. I wanted it to run at 60 frames per second for a live application, and if you do the math, that means you have a hard budget of 16 milliseconds per frame, not over 100. So I had a lot of work to do. We did run through a couple of major categories of effort. I did a ton of multi-threading code. Does anybody here have any experience with JavaScript? Has anybody ever told you that JavaScript's asynchronicity is superior to threading? Or that it's the same, that it can accomplish the same job? I've heard that. It's not true. And multi-threading, while incredibly powerful, I can see why they didn't touch it with a 10-foot pole in JavaScript, because, you know, sometimes you run into memory corruption bugs. Sometimes you run into deadlocks. Sometimes you spend hours and hours and hours trying to figure out why your program isn't working correctly. And it turns out you did something really stupid. That's the magic of multi-threading. But at the same time, it made my program really fast, so yay for that. Did end up pruning a ton of unnecessary work, which helped enormously. As I demonstrated, we started out with optical flow tracking for the markers. So trying to do things like use optical flow tracking algorithms to try to keep track of the markers from frame to frame turned out to be the slowest and the most useless thing for us to do. And the reason is because all of our algorithms to detect the position of the marker initially ran an order of magnitude faster than the algorithm to keep track of the marker's position from frame to frame. So we could just run every single frame a totally fresh detection, and it turned out to be a much, much better solution. The only reason I did this in the first place was because I was biased in my thinking toward a particular solution, right? But we were able to solve it much, much more efficiently by just not doing any of the things that I thought were right, which let that be a lesson to you. Also, GPU acceleration. Turned out that GPUs are really, really great at some of these kinds of things. So any application, any part of the application that I was able to offload to the GPU gave us, another big speed up and actually got us over the line. So what it ended up looking like was this. And man, does it work great now. I've definitely seen it run over 100 frames per second, pulling data off of an SSD. It runs about 60 frames a second when it's doing, working with a camera. That's my fastest camera. I don't have a camera that produces HD video faster than that. So I don't have to worry about optimization anymore. So future work, basically a user interface would be good. I would like for other people to be able to leverage this. And right now it's a command line program, so that's not for everybody. So user interface would be great. And some improved machine learning models. Frankly, the ones I mentioned already, there are some deficiencies in the training and in the training data. And as a result, the models don't always do exactly what I want them to do. So the hard part there is, how do I get enough data without introducing bias? I don't want a model that's just good at detecting like a white male's face. I want to be able to have a better model. So adding tests, there's no unit tests. Sorry if you're into test-driven development. I was gonna write tests, I promise. I actually downloaded a testing framework. It was the first thing that I linked into the project, was a testing framework. And then I just never wrote any tests. I don't know what to say, So that would be great if you're into, contributing to open source projects. Help me write tests, because this thing needs help. And speaking of open source, I really want to embrace the ethos of it being an open source project. I've put the code up there, but it's not just up there. It's actually licensed under an MIT license. And I have all the infrastructure necessary via GitHub and Taiga to have a backlog and to manage pull requests and all of those kinds of things. So I'm very interested in if anybody wants to take a look at it, poke around on it. I mean, even just frankly see if it compiles on your box, and if not, let me know because that would be good. So yeah, please join the effort. Now, we have reached that really scary time in the presentation where we try to make this work live. And my fear is that it will not work live, but we're going to give it a try anyway. So please give us a moment.
And now, before the next show starts, let's enjoy an intermission. You'll find our snack bar chock full of good things to eat and drink. Tasty, tempting hot dogs, thirst-quenching soft drinks, fresh, crunchy popcorn, a complete assortment of delicious candy, and a full line of cigarettes. You've plenty of time, so visit the snack bar now. A tasty treat will double your enjoyment.
I did say 1 moment. That was a lie. It's going to be a minute, not a moment.
Let's all go to the lobby. Let's all go to the lobby. Let's all go to the lobby to get ourselves a treat.
Delicious things to eat.
The popcorn can't be beat. The sparkling drinks are just dandy. The chocolate bars and the candy. So let's all go to the lobby to get ourselves a treat. Let's all go to the lobby to get ourselves a treat.
The next show will start in 2 minutes.
Yes, Toddy, the chocolate malt in a can.
It's so good hot. It's so good cold.
It hits the spot with young and old.
Yes, toddy pleases everybody. Delicious chocolate malted toddy, made with rich, real milk, not powdered milk.
So come and get it, everybody. It's time to drink your chocolate toddy.
Just a minute, folks.
Well, good afternoon, Snufflefungus. How are you doing today?
I'm doing stupendous. It's such a great day today. Well, my mic isn't on.
Okay, we're good. Oh, sorry about that. I was distracted. Man, I'm actually pretty tired. It's a good day, but I'm exhausted from working on this presentation.
Do you want some coffee? I made it myself.
You made it yourself? Is that safe?
No.
All right then. Okay.
Do you want some?
Well, yeah. I'll take a cup. I'm pretty tired after all.
Do you like it? It's my own recipe.
Oh, yeah. That's really full-bodied.
You're too kind.
Yeah. So what's in that coffee?
You're not going to stop drinking it, are you?
Nope. No, I'm not.
Well, great, because I put hazelnuts in it and habanero seeds too.
Why?
For a sophisticated aftertaste.
Oh. Okay.
Don't stop drinking on my account.
No. Oh man. So what else did you put in here?
Chocolate, but not the chips. I used cocoa powder.
The unsweetened powder.
Yep. Because chocolate's yummy.
Yep.
I also used some bouillon cubes that I found in the back of the cupboard.
Oh, snuffle fungus. Why? Why did you choose these things?
Mine had suggested I make a bold and unique coffee for you. So basically, I considered anything in the kitchen that was black or brown or smelled good. Because I know when you make coffee, you talk about how it smells good.
Oh, yeah, I do. Normally, when I make coffee, it smells like coffee. Did you choose things that smelled like coffee?
I don't know. I don't even have a nose.
Of course you don't. What else did you put in here?
Oh, sorry. I forgot the most important ingredient. You'll never guess.
The most important ingredient is coffee, I would hope, since it is coffee.
No, silly. Lina said if I put coffee in it, that would be boring and predictable. So instead, I used old motor oil. Well, I guess that's all, folks. Thanks for joining us. And we'll see you again next time. Bye!
And guys, my brother, Peter Markley, as the live cartoon character Snufflebungus. All right, so with those shenanigans out of the way, that brings us to questions. Who's got questions?
Describe your system.
Okay, hardware or software?
Hardware first, then software.
Okay, so it's a Linux PC. It's got an i7 processor, 8 hyperthreads, and I have a GTX 1070 graphics card, which is doing all of the CUDA, GPU accelerated algorithms. Software, like I said, it's Linux. This is one of the machines, that I use, that I put Ubuntu on. So this is Ubuntu 18.04, the LTS. And the reason for that is I want to be able to target it as a standard distro that people use. I'm actually more of a Fedora guy myself, but making sure that it works properly on Ubuntu is important. So then I have all the SDKs installed. I have YerFace built and able to run under those circumstances. And then we use Blender as the rendering and animation for taking the animation data that's produced live by YerFace, pushes it in through a Blender plugin that I wrote, which is also open source. Does that answer the question?
So, how much of a lag is there? So we couldn't see his face because he was facing towards the camera. But how much of a lag is there between it recognizing wherever points and other stuff, and then rendering it on the screen there?
Yeah. So the answer is it depends. And the most variable part of the pipeline is the input. Video and audio tends to be buffered, so it's really important to get. And I can't actually measure that because I don't have the equipment to measure that. But I will say from the point where we get a decoded frame to the point where you see it on the screen is less than 10 milliseconds.
So the audio is synced up differently than the rendering stuff, right? The audio is live or something.
Yeah, so the audio is, we're piping it into the computer for lip syncing, and also piping it out directly to the mixer so that we can hear it, so that you can all hear it. I will say the lip syncing algorithm for live is weaker than the offline algorithm, and the reason for that is because Sphinx just doesn't have the ability to run completely online. It takes a few hundred milliseconds to be confident about a breakdown, and we just can't wait that long. There's no way. So instead, for live lip syncing, I just use the amplitude of the waveform as an indicator for speech amount, So we're doing our best. Thank you. Any other questions?
Have you looked at tracking more than just the face? Have you looked at doing like maybe ears, even though they don't move that much, or shoulders, arms? Are you going to expand your characters as well?
Yeah. So I know for my purposes, what I'm looking to do, I will probably have a need for skeletal animation, and my guess is that I'm going to use some coherent data coming from like depth cameras, and like if you look at open source software for the Microsoft Kinect, there's a good handful of solutions for skeletal animation that tracks limbs and overall body pose and things like that. It really was when you got down to the face that all the solutions I found that were freely available were just totally lacking. So when I get there, I'll probably just use another tool.
I guess I have a bunch of questions.
Go for it.
The other one
we got a few minutes.
This is more directed towards your brother. How do you feel the facial animation helps with your delivery of lines? Do you feel like it inhibits your ability to imagine the character, or does it make it feel more realistic for you?
It's another thing to worry about,
actually.
Okay.
So.
It's funny because actually having to perform facially, for people who have a long history of voice acting, which we have been doing, based on our production, we've been doing that for a long time, having to inject facial performance into that really creates a problem. It creates a challenge for delivering certain lines using certain voices, because, if you've ever seen videos of people voice acting, professional voice actors, they tend to make really strange faces while doing it. And it's because when you contort your face into different shapes, it allows you to make different sounds. So
there was a particular line in the one we did for Linux Fest where Snuffy was supposed to scream and also frown, because he wasn't screaming happy, he was screaming scared. And I found that I couldn't do Snuffy's voice in the scream while frowning in such a way that the performance capture could tell it was a frown. So Snuffy kept smile screaming.
I mean, part of the feature there is that you actually have to smile and
right,
in order to make that high-pitched voice. So, it creates a unique set of challenges.
Do you find that you're exaggerating facial movements now that you were not doing previously, before you were doing motion capture, correct?
Well, for voice acting, I wasn't paying any attention to all of my faces.
So would you say it as like a future optimization to extrapolate exaggerations into the character from very subtle movements of the face so that you can deliver the performance in a more natural way, but then you still translate that into a cartoonish hyperbole?
Yeah, so exaggerating the pose and providing eyebrows like jumping off the head and things like that. That's actually a fundamental part of the design, but it's difficult to tune. And part of the reason why it works for us is, and why we're able to do that in the first place, is because we're not doing mesh retargeting. And in Hollywood, it's all about mesh retargeting. You work on getting your input mesh, and you use that input for basically calculating mesh deformations on the output mesh. And we don't even bother with that. What we're doing is we're using these points as input points to Python code. And then that Python code, we can have an exponential curve in there if we want to have it just go like crazy. But again, because our models aren't always the best, it can make it difficult. Like the problem he was talking about with frowning, it literally, the mouth will start to scramble and it'll start to lose track of the mouth completely if you frown more than a small amount. And so that's really the opportunity there for better models to give us better inputs so that then we can do more of that.
And I might miss something, but the coding of that machine learning part, that's being done using Carnegie Mellon's open source. So is the data stored there, or is the decoding done there and then sent back over the web or something?
No, everything's live. So CMU Sphinx is what we're using for speech decoding, and they have a machine learning model that is freely available, which we can download and run locally. DLib provides the facial recognition model, which we can download and run locally. And they also provide the facial landmark recovery model, which we can download and run locally. So if we had to wait for network latency to go out and come back, it would be completely impossible to do live.
So just a follow-up question on that. So when you download it and run it locally, is that particular PC then better at recognizing your brother then, and then getting better? Is it storing that information, or is it decoding each time that it's a frown or a smile or something?
Everything is, it is not doing online training. That would be a model that, if you were able to do online reinforcement training, then you could continue to accumulate data locally. Obviously that technology does exist, but we're not using it. So what we're doing is we're taking the static pre-trained model and just executing it over and over on a sequence of images. So hypothetically, we could always run the same model on a particular frame and get deterministic results. But the flip side of that is that all the tools that we're using, they're designed to support not only running models, but also building and training models. So we would be able to use this foundation that we've built to use better training data and either the same network or an enhanced network to train that network to create our own unique model, which would then we would have to distribute as part of our package. Does that answer the question?
Yeah.
Okay. So we're about at time here. Maybe time for one, maybe two more questions.
What made you settle on 60 frames per second, other than that's the refresh rate of monitors? I know, looking at some other animations, 30 frames is considered good for smooth play, and some animations, like Matt Groening's animations, go down as low as 16 frames in a lot of sections.
Yeah, that's a great question. And actually, when we are doing rendering out from Blender and composing the output renders, we're targeting 29.97 frames because that's the same frame rate as our camera, the standard NTSC. The reason I want YerFace to run at 60 frames a second is so that it has more data. And in particular, some of the smoothing algorithms, they take every sample for the past n seconds, where n is some fraction of a second, and it'll take all the samples and apply a nonlinear curve to weight the average. So that basically the more samples you have inside that window, the smoother the result will be. And because the models, again, going back to the machine learning models, even just the tiniest amount of noise in the sensor is going to cause them to jitter ridiculously. So we have to apply smoothing, and the faster the frame rate is, the more information we get. One more?
So you're putting episodes of this show on your website, or?
I appreciate that question because that's what I'm getting at here. We have not relaunched the show yet. Okay. The audio podcast, like I said, ended in 2010. I've been working on this solution for a decade. Obviously, YerFace has only been for the past year. We really started to get traction on it. I'm hoping to relaunch the show as a video show on YouTube either at the end of this year or the beginning of next year. And so you can go to mbe.tv for Markley Bros Entertainment .television and see what we're doing, and hopefully we'll be live soon. All right, guys, thank you so much again for coming, and enjoy the rest of the show.